Maybe not. Live. There we go. Okay. It is 5:14. Test tomorrow. Okay, so ratio. Okay. We need a trig ratio, which means we just want the fraction only, okay? So I just want the fraction. Ratio is a fraction, okay? So what I want is, for each trig, so what I want is the sine of p. I want the cosine of p, and I want the tangent of p. I don't want you to find p, I just want you to set up the fraction, all right? So if I look up above, sine is the opposite over the hypotenuse. So if I look at P, and I'm going to use a pencil because I'm going to erase this when I go to the other angle, the 8 is its opposite because of our stand at P, and I threw the lake to the opposite side of the lake. The 15 is the adjacent, and of course the 17, which is the longest side opposite 90, is the hypotenuse. Okay, so here we go. So if I want to do the sine of P, it's going to be its opposite over hypotenuse, so it's just 8 over 17. That is the answer. That's all I want. That's all I want. Cosine of P is the adjacent over the hypotenuse, just 15 over 17. That's all I want.
There were a few problems like this in the time.
Yeah, there probably were. I'm sure there were. And you might see more tomorrow. You never know. And the tangent of P is the opposite of hypotenuse, which is the 8 over 17. Okay, now we also want to do it for angle G. Yes, Hayden. Question.
Is it 15?
Yeah, it is. Yep. Thank you. It is 8 over 15. Nice job. Who said that? Nice job. So let's now look at angle G. So if I go to angle G, a couple things change. Okay. If I go to angle G, now all of a sudden the 15. If I'm standing here, I throw my rock across the lake. The 15 is the opposite, and the 8 is the adjacent. The 17 stays the hypotenuse because it's still the longest side opposite 90. Okay, so we're going to do the same thing, but this time with G. So I'll go sine of G, cosine of G, and tangent of G. All right, no problem, I can do this. So sine, which is from G, right? Sine, which is its opposite over its hypotenuse, is the 15 over the 17. Cosine of G, which is the adjacent over the hypotenuse. And then finally tangent of G, which is its opposite, 15 over 8, right? Okay, can you do that tomorrow? Right?
Yes.
Good.
Should be very easy.
Should be easy. Trig can be one of those tests where I think everybody can be successful if you're trying, right? If you're trying, it should be easy. Okay, now, example 2. Problem number 2, we actually have to solve, okay? So, we don't know angle A. We don't know little a, that's side A. And we don't know little t, that's side T, okay? What I'm going to do first is probably go for the easy stuff. Let's go for the easy stuff, and that's going to be angle A. So, angle A, so the measure of angle A is simply going to be 90 minus 50. Because the two angles are complementary. So 90 minus 50 is 40 degrees, okay? That's easy. And I'll put my 40 in to my triangle just because then I have more that I can work with, okay? Now, I could either find little a or little t. It does not matter, okay? And I can pick either angle to work with. Again, it does not matter. I just picked A. It does not matter. I like A. I'm going to find little a. You could have found t, but I'm going to find little a. And then I'm going to use the 12, okay? So always start with your angle. Pick an angle. Because then you get your names once you start with your angle. Because then you get the name. This one's going to be my opposite. And the 12 is going to be my hypotenuse, okay? So let's go for little a. Opposite hypotenuse is going to be sine, right? So a sine of theta, right up there. Theta. But theta means angle, right? And my angle is my 40. So instead of putting theta, let's put 40. Sine of theta, or sine of my angle, sine of 40, is equal to my opposite, which is my a, my little a, over my hypotenuse, which is 12. Now I'm just going to multiply the 12, right? Take the 12, multiply it up there. Borrow Max's calculator. Thanks, Max. Check my mode, make sure my mode's in the right mode. Okay, I'm good at my mode, so I'm just going to go 12 times the sine of 40, and I get an answer of about 7.7. So 12 times the sine of 40 is about 7.7. So that's little a. Okay? Okay, little t. Am I going too fast? Okay, little t. Now I've got two choices. I could do Pythagoras Theorem. It'll work. I can go 7.7 squared plus t squared equals 12 squared. Or I'm going to just use trig. Okay, so we use a different color. Same thing, pick an angle. I like the 40. I'm going to find t, and I'm going to use the 12. My little t is my adjacent, right? Okay, so instead of sine, I'm going to use cosine. Same process, so I'm going to go cosine of theta. But that theta symbol means angle. My angle is 40 degrees, is equal to my adjacent, which is t, over hypotenuse 12. Okay, how am I doing? Okay, multiply up the 12, put right there. 12 times the cosine of 40 is equal to t. I'm just going to use my calculator. 12 cosine 40. I get an answer of about 9.2. Okay, how's that? Thumbs up? So you can do this tomorrow, can't you? You can do this? No problem at all. Okay, 3. Am I doing okay on pacing? Am I doing okay? All right, 3. So I don't know an angle. So what I'm going to have to do is use the inverse button. But let's go there first. So I don't know angle B. I don't know angle N. So it doesn't matter. Dylan, what do you want to find? B or N? Does not matter to me.
B.
B it is. Okay. So we're going to use tangent. How do I know that? Opposite, adjacent. Okay. So there's my opposite, and there's my adjacent. So I'm going to definitely use tangent. So I'm going to go tangent, and it says tangent. It's tangent of theta. Theta means angle, right? But I'm going to write B because that's my angle, right? I'm not going to write theta. I'm going to write B because theta means angle. And the angle, Dylan said, let's find angle B, okay? Tangent B is equal to my opposite, which is my 10, over my adjacent, which is 3, okay? So I need to use my second or my inverse button. So I'm going to go really tangent inverse of 10 divided by 3. And I'm going to just put that in my calculus. See, I'm just going to go like this. We'll go tangent inverse of 10 divided by 3. And I get an answer of about 73.3 degrees. So angle B is about 73.3 degrees. Okay. How's my pacing? Yes, Tony. Great question. If you want to find the angle, you have to have the -1. And those are the blue buttons. So these are my get the angle buttons, okay? So I go sine blue, I get the -1. If I go cosine -1, I get that one. If I go blue, I get that one. So these are the buttons you push when you want to find the angle. Okay, good question. Okay, now, how about angle N? Now, angle N is pretty easy because these two, B and N, make 90, right? So okay, I can do that. I can say, so angle N, the measure of angle N is just equal to 90 minus 73.3, right? 90 minus 73.3, and I get an answer about 16.7 degrees. Okay, so angle N is a 16.3 degrees. And then finally, little e, or the hypotenuse, okay? And I'm just going to use Pythagoras Theorem, because those are nice numbers, right? I'm just going to use Pythagoras Theorem, so I'm going to go, okay, I'm going to go my 3 squared plus my 10 squared equals my c squared, or little e squared, okay? I get 9 plus 100 equals my little e squared, right? Which is 109. And I'm just going to take the square root of that. What's the square root of 109? Square root of 109. About 10.44. So I get about 10.44. Okay, how am I doing? Is my pacing okay? Pacing okay? You sure? I'm not going too fast for anybody, right? Okay, now number 4. 2 ways to do it. The easy way or the harder way. I'm going to do it the easy way. It's a special right. It's one of those. Now you can use trig. You can use, like, for instance, sine or cosine. You could. You could use Pythagoras Theorem. You could. But I'm going to use the special right triangle because it's half a square. 45, 45, 8, 8. This is just 8 times the square root of 2. That's it. I'm using that special triangle there. Okay, it's half a square. 8, 8, 8 squared to 2. Okay? Number 5. Again, it's a special triangle. I could use, if I wanted to find x and y, I could use trig, I could use sine or cosine. I could, right? But I'm just going to use my special right triangle. So this side, the hypotenuse is twice as big as this side. The hypotenuse is twice as big as the short leg. So this is 20, this is 10. And whatever this is 10. This side is going to be 10 times the square root of 3. So this is going to be 10 square root of 3. And I got it from that special right triangle there. And again, if you want to use sine or cosine to get these, it'll work. Okay, that's fine, but I'm just going to go and do it the easy way, okay? Okay, you guys ready for 6? So 6 is also the special right triangle, but the bummer about this one, I look up there, see how short I am? See right there, it's got a square root of 3, and that's an 18, right? So the 18 is equal to some x squared root of 3, okay? So if I want to find x, I'm just going to divide. I'm going to solve for x. I'm just going to solve. So divide by the square root of 3, divide by the square root of 3, and it is 6 square root of 3. Yeah, that wasn't so hard, was it? And again, if you want to use cosine to get that answer, actually you'd have to use tangent. You get a decimal answer, but you could have used it. You could have used tangent. That's easy for me, okay? All right, you guys ready for 7?
Oh,
Let's
no.
graph it. If you need graph paper, hopefully you have it, okay? All right, let me do 7. I'm going to do 7 on a piece of graph paper. Try and do a nice job of graphing it. All right. And I'll run. Okay, let's see what I got. And 4, 3, right? There's R. Negative 2, 3. There's S. And negative 2. Negative 5. 1, 2, 3, 4, 5. Way down there, okay? And that's T. Alright? So I graphed it in. I'm going to connect the dots. Draw my triangle. And it's definitely a right triangle. You guys agree? Definitely a right triangle. Let's see. Okay. 1, 2, 3, 4, 5, 6. This side is 6. 1, 2, 3, 4, 5, 6, 7, 8. This side is 8, right? Okay, I just count with the squares. That's the easiest way to do it, right? So if I want angle R, Tony, I'm not picking on you, but this is going to help answer your question, okay? So this is the time I'm going to use one of these blue buttons because I need to find the angle, okay? So if I want to find R, from R, the 8 is my opposite side, right? And the 6 is my adjacent side because it's next to it, okay? So I look up there, opposite adjacent, I'm going to say, how about tangent, okay? Guys okay with that? So go tangent of R is equal to the 8 over 6. Now I used R because the symbol theta means angle. And the angle I want is R, right? And the opposite is the 8 over that. Now 20, I got to find the angle. So I'm going to push one of those little -1 buttons, okay? But I'm going to do the tangent. So 20, I'm going to go and do tangent inverse of 8 over 6. And in my calculator, I'm just going to do that, okay? So I'm going to go just like this. I'm going to go second tan, 8 divided by 6, okay? And then I'm going to get an answer about 53.1 degrees. So the measure of angle R is about 53.1 degrees, okay? Awesome. Okay, now, if I've got to find RT, that's this side here, right? I'm just going to use Pythagoras Theorem. Okay, so I'm going to go 6 squared plus 8 squared equals, call it C squared, okay, because you guys like A squared plus B squared equals C squared, right? 36 plus 64 equals C squared, right? I'm just using Pythagoras Theorem, that's all. A squared plus B squared equals C squared. 100 equals C squared. Square root. And I get 10. You can do that tomorrow, can't you? Heck yeah, pretty easy. Trigonometry is easy, isn't it? Sounds hard. A word like trigonometry's got to be hard, right? It's not. Easy. Easy stuff. Okay. All right, story problems. So remember, when you do a story problem, we're doing right triangle trig. So they're not that hard, okay? So if you draw a picture, we can probably do it. Okay, number 8. I have an 18-foot ladder leans against a 12-foot wall, okay? So we go just draw a picture, okay? Providing the wall is straight, we can use a right triangle, okay? So I've got a 12-foot wall and an 18-foot ladder, okay? What is the angle formed by the ladder and the ground? That's right there, right? You guys agree? It's got to be that angle, right? So, from the angle, always start with the angle. That's my opposite side. And the 18 is my hypotenuse. Opposite and hypotenuse has to be sine. Sine of my angle, right? Which is equal to, according to the chart up there, the opposite, which is 12, of the hypotenuse, which is 18. Tony, what button do I need to push if I want to find the angle?
The blue one.
Smart girl, exactly. So I'm going to go sine inverse 12 divided by 18. So I'm just going to go, okay, sine inverse 12 divided by 18, and I can answer about 41.8 degrees. Thumbs up, you can do that tomorrow? Awesome. Okay, number 9. Now shadows are on the ground, by the way. A lot of kids want to do the...
Shadows from the air.
Well, they want to think about it's cast from there, but shadows are on the ground, right? Everybody agree? Shadows are on the ground. They're not coming down. That's how you cast a shadow, but the shadows are on the ground, okay? So the shadow of a tree on the ground is 18 feet long, and the angle of elevation to the top of the tree is 54. What's the height of the tree? Okay, so let's draw a picture, okay? So it's going to look something like this. Here's my shadow, which is 18. Here's my tree, I'll call it T, and my angle is 54 degrees, okay? So everything starts from the angle. Okay, 54 degrees, that's my opposite side. And the 18 is my adjacent side, okay? So let's see what we got. Opposite, adjacent. Opposite, adjacent. Well, tangent. You have tangent? So let's go tangent of theta, but theta is just another symbol for just angle. Theta means angle, so it's 54 degrees, equals the opposite, which is t, over the adjacent, which is 18. Okay. Multiply up the 18, right? 18, so I'm going to go 18 times the tangent of 54 equals t, and I'm just going to use my calculator. 18 tangent 54, and I get an answer of about 24.8. That'd be in terms of feet, I assume. Yeah. How am I doing? We're almost done, really. We're getting close. Thumbs up? All right. 10. So a wheelchair ramp is made by having the length of the ramp 4 feet and the height of the ramp be inches. Now you got to be careful. And tomorrow you got to be careful too. Let me highlight these words, okay? Feet and inches, okay? Feet and inches. You guys see it? See the difference? So let's just make this right off the bat 48 inches. You okay if I just make that 48 inches? 12 inches to a foot. Let's change inches to inches, okay? So let me build my ramp. The ramp is 48. So the 48 goes there. That's the ramp. Don't put the 48 here. That's the ramp. You're going up that, right? And the height is 4, okay? The angle I'm looking for is right there. Theta, okay? All right. Opposite. Hypotenuse, right? Let's use sine of theta equals the opposite over the hypotenuse. Okay, Tony, smart girl, what button am I going to push to find the angle?
The blue one.
Perfect. So we're going to go sine inverse of 4 out of 48. And let's see what my calculator tells me it is. So I'm going to go second sine, so I get the blue one, right? 4 divided by 48, and I get about a 4.8 degree angle. which is good. It should be small if it's a wheelchair ramp, right? Grandma can get up that wheelchair ramp, huh? It's going to be okay. Okay, 11. We're close. So an airplane flying at an elevation of 8,000 feet starts to descend toward an airport with an angle of depression of 8 degrees, okay? So here's my airplane, right? And it's going to come descending down to my airport. Okay, here's my airport, right? It's at a height of 8,000 feet, but its angle of depression is 8 degrees, okay? Now there's two things we could do. We could use the upper triangle, because there is another triangle up here, right? Because what we want to find is this distance here. All right, we want to find that. We could use the upper one, or we can use the lower one. Probably the lower one looks better, right? So if this is 8 degrees, then this is 82 degrees, or this is 8 degrees. You okay? Does that make sense why I made that 82? Because they have to make 90. Or you can go 8 here and 8 here, right? So let's do this. Let's use this triangle here. We'll use the 82, okay? How about cosine? How about cosine? Adjacent, and this is my hypotenuse. So I'm going to go cosine. So I'll go cosine of theta. Well, theta is my angle. Cosine of 82 degrees equals my adjacent, which is 8,000, divided by my x. Okay, now, if x is on the bottom, we're going to switch places and divide. Okay, you can't, when you multiply by the x, it comes up here. Then you got to divide by the cosine. So we're going to go x is equal to, we're going to switch places. 8,000 divided by cosine of 82. Okay, and I'm just going to use my calculator. Let's see what that is. So I'm just put it in just like this. I'm going to go 8,000 divided by cosine of 82. And I can answer about 57,000. Big number, huh? 57,482 feet, and that is correct, totally correct. I'm going to divide it, I'm going to make it in terms of miles. You don't have to. Being a math nerd that I am, I'm going to divide this by 5,280 because that's how many feet are in a mile, right? You don't have to do this, I'm just going to do it. So he's about 10, almost about 11 miles out, okay? And that makes more sense. Airplane's coming in about 11 miles out, right? So he's about 10.9 miles, but you don't have to put that down. It just looks better, right? Makes more sense. Okay, last but not least, almost there. We want the area. Find the base, BC, and the height of the triangle, and the area. We got to find all three, okay? This isn't hard, but the problem is we don't have a right triangle. So let's make one. Yeah, cut it in half. You guys agree? Cut it right down half. So I'm going to do that. You're way ahead of me. I like that. That's awesome. Yep, totally agree, okay? Yep. 34 degrees here. 90, right? H. Yeah, 10's just going to say 10. Okay, real quick. Does not matter. Doesn't matter at all. Brett, do you want to find the height first or the base first? It doesn't matter. Base it is. Let's find the base. So we're going to use sine, opposite, hypotenuse. So I'm going to find, so to find the base, I'm going to go sine of 34 equals the opposite, which is b over my hypotenuse is 10, right? Opposite over hypotenuse. Multiply by 10, bring that up. 10. Sine of 34 is the b. Okay, I can do that. I can go 10 sine 34, and I get an answer of about 5.6. But the whole base of the triangle is really going to be double that. Does that make sense? I'm going to double that, right? 5.6 times 2 is that 11.2. So the base is 11.2. Okay, I just doubled it. Okay, now let's find the height. So if height, I'm just going to use cosine. All right, you're here. Giovanni, I'm working on the review right now. If you want the review, it's right here, Giovanni. And then I'll give you a copy of my review, okay? So let's find the height. So I'm going to use cosine because I've got my adjacent. So let's go cosine of 34 is equal to my h, which is my adjacent over my 10. Okay, adjacent over hypotenuse. Here's my adjacent and my hypotenuse. I multiply by 10. 10. Cosine 34 is equal to h, and again, just boom, boom, 10. Cosine 34, and I get an answer of about 8.2. Nope, 8.3. I rounded wrong. 8.3. Okay, so now the height is that. Okay, got my base. Now, last but not least, let's find the area of this darn thing. Well, that's easy. 1/2 base, because the base is 11.2, times the height, because that's how you find the area of a triangle, right? 1/2 base times height. So let's do 0.5 times 11.2 times 8.3, and we get an answer of about 46.5, and that'd be in terms of centimeters squared. So tomorrow's test is just like this, just like this.